Right, so we just finished doing large samples, and now we're going to do small samples. All right, remember the t-test is when you have the sample standard deviation. All right, we're going through the exact same steps, except now we're going to use the t-test. We have to use a table, like the t-chart, and I'll also teach you to do the p-value. Yeah. All right, t-distribution is when you don't know the populations, but you know the sample standard deviation. It's random. It's either greater than 30, or if it's less than 30, it tells us that it's normally distributed. We're going to go through the exact same steps. All right, and so again, you know, being able to adapt to technology is a pretty important skill. And so we're going to go do the same thing, except now when we push stat and we go over to test, we're going to put t-test, okay? And this data is when we have a list of data and we type it in like L1 or something, and then stats is where they give us the information, and then we pick two-tailed, we pick left, or we pick right-tailed, and then we would do calculate, and it will give us a whole bunch of information. We can use that information to do the most important part, which is analyze. All right, so let's look at this problem and analyze it. A medical investigation. This is not the right document, guys. Oh my gosh. Hang on. This t-test. Hang on, I'm so confused right now. It's not hard to do. All right, it is the right document. All right, I don't know. You know, blonde. Okay. Move on. All right, medical investigation claims that the average number of infections per week in a hospital is 16.3. All right, a random sample of 10 weeks had a mean number of 17.7. The sample standard deviation, that's how we know we need to use T. S is letter for sample standard deviation, 1.8. Is there enough evidence to reject the investigator's claim? And alpha is 0.05. All right, so this should say is greater than. I don't know why it's missing that. All right, so is greater than 16.3. All right, so that's the claim. That means that's the alternative, and the null is equal to. All right, so push that. I'm doing it on my calculator. All right, go to test, t-test, and we're gonna be in stats. All right, so mu, this u thing right here is called mu. All right, it's gonna be 16.3. X bar 17.7. S is 1.8. N was 10, and we want y'all, I don't remember. I said that was greater than, and I wrote less than, right? Okay, is greater than, so it should be like this. Okay, and then go pick greater than. All right, that's your calculator. All right, so all that information right there, if you're within, you know, a few tenths, great. your calculator might run differently. If you got like p equals 14, that's wrong. Or 3.2, or negative 1.6. If you got p equals 2.46 or 2.39, that's all fine. It's all in the same ballpark. Do it outside of that. All right, so I'm going to write down this information. All right, p equals 2.5, p equals 0.02. We got x bar was 17.7. Okay. SX, that's the sample standard deviation. Sample standard deviation, and is 10. Okay. So we learned in the other video that it doesn't matter if we use the traditional method or if we use the p-value method, as long as your math is correct and your logical thought process is correct, you're going to get the same answer. All right, so I'm going to just show you in this way because the t-chart can be kind of confusing. I'm going to show you how to use the p-value method. Okay, and remember, I'm going to show you how to use the p-value method for a t-test versus the traditional as well. All right, remember the p, we're going to compare it to the alpha. P, compare it to the alpha. And if it's less than alpha, we reject that whole. All right, we're going to reject the null. And then if it's greater than, we accept. All right. So let's compare our p and our alpha. Our p was 0.02. Our alpha is 0.05. That guy is greater. And so since it's greater, we're going to reject the HO, the null. And that means we accept the alternative. All right, so then we would write, there is enough evidence to accept that the mean is greater than 16.3. Okay, or you could say there is enough evidence to reject that the mean is not 16.3. Okay, all right, let's do the same kind of problem, different information. All right, this time we have a list of data. So I'm going to go on my calculator and go to list and then edit. And I'm going to type all that in list one. 82,000, do it with me. 68,000, 7,200, 75,600, 83,500, 679,000. So I went on the list and I went in list one. I said, all right, and so now we can do the run. According to payscale.com, the average starting price for a nurse, $79,500. Those are zeros. A researcher wants to test the claim that it's less than $79,500. Less than $79,500. All right, and so the claim is always the alternative. A random sample of 8 nurses were selected and their starting salaries are below. Is there enough evidence to support that alpha is 0.01? All right, assume it's normal. If this particular problem, because it only had 8, which is less than 30, if it didn't say it was normally distributed, we couldn't even do it. All right, so we need to make sure we have all the information and all the assumptions are met. All right, so I'm going in my calculator. I'm going to push statistics, stat. I'm going to go to test, and I'm going to go to t-test. All right, now I'm going to make sure data is highlighted because I have this list of data that I need to put. All right, it said mu was 79500, and we're doing less than. All right, so make sure you're time, and we need to be in data with this. All right, so again, if your t-value or p-value are remotely close, that's great. If it's, I don't know, p equals 1.2, there's something totally wrong. All right, I'm just going to write all that information down. 1.77, P is 0.06, X bar is 7550, sample standard deviation is 6937.7, and is 8. All right, so when we're doing the t-test, and look, hey, we didn't see anything on this problem about population standard deviation or sample standard deviation. However, because we have a sample, we need to because we have a sample, we need to calculate the sample standard deviation, right? So that's how we know we use the t-test. All right, I'm going to compare P and alpha. All right, P was 0.06. Alpha we decided was going to be 0.10. No. All right, and this guy is greater. And so when it's less than, we reject the hoe. All right, and so that means we're going to accept. Ooh, not what I wanted, not what I wanted. Accept that the mean is less than 79.5. All right, let's do the same exact problem. Okay? And I'm going to give you a different alpha, and let's just see what happens. All right, what if I said, right, what if I said alpha was 0.05, which is the most common one to use? All right, that means that you're 95% sure you're going to be correct, and 5% you might be wrong. All right, so if alpha was 0.05, we're going to compare P and alpha. P was 0.06, alpha is 0.05, and this guy's bigger. So when it's bigger, we're going to accept the hoe. We're going to accept the null. And so that means there's enough evidence to accept that the mean is 79.5. All right, so let's look at this real quick and what like the implications this is. When we did this guy and we wanted to be 90% sure that we were correct, we can be 90% sure that the mean is less than that it's less than 79,500. Okay. However, if we want to up our confidence and we'll be like, no, I'm not 90% sure, I'm 95% sure, which is I'm even more confident, right? What happens here is we change, like it's a whole different conclusion. We accept that it is exactly, or within a few $100, right, of 79.5. Okay, so we got more confident, and then it kind of changes our results because we don't want to be wrong about that. Let's do another problem. Much talks about the p-value, but I've been talking about it. Let's do this guy right here. All right, a physician claims intake is greater than all. 15 joggers mean is 40.6, and the standard deviation is 6. If the average adult is 36.7, all right, that's the null, that's the alternative, and we want to see if there's enough at 0.05. So go to stat, test, type it in, statistics, and we're going to do 36.7, 6. Oh. All right, so we're going to type it in, and then we get a p-value of 0.01. Compare p to alpha, 0.05. That one's greater, and so we reject the whole, which means we accept the fact that it is greater than 36.7. So it's the same thing, just a different test.